Good afternoon once again. I'm Dr. Nazeem Edwards. I'm working at Stellenbosch University in South Africa. I was really hoping to come to Turkey, but unfortunately travels and so on, obviously we've been banned. So hopefully next year it might be a better opportunity. But nevertheless, I'd like to share with you a study that's been conducted at our university. I'm in teacher education. And so what's happened is I've got some students have been working on the project as well in science education, in which we have been looking mostly at pedagogy that our students in what is known as our Bachelor of Education course, that they sort of implement in the class. So just as a background, just to offer you, these students quite often haven't had any real science up to the what we call the matric level, the grade 12 level, before they enter university. Some stopped at grade 9 level. So their content knowledge actually is quite poor. But what we are doing is to prepare them actually for the intermediate phase, which is from grades 4 up to grade 6. And so so it's then a mix of, as the previous speaker alerted to, pedagogical content knowledge. So mixing the content, you know, giving them sufficient knowledge, or making up perhaps the backlogs that they have, as well as then to prepare them for the classroom as science teachers. So there's a shot of our building. I work on the top floor and in the curriculum studies department. And yes, we're also under lockdown at the moment. So, but we're slowly moving back to sort of a hybrid mode. So I was teaching a bit for the first time after a year, more than a year yesterday, a bit of face-to-face at our campus. So in this study, sorry, just to go back to the title of the study, we looked at the investigating pre-service science teachers' representational competence and fluency, and we're comparing actually what they are doing in physics as well as in chemistry. So just by way of background, in physics, there are multiple external representations, which include formulae, graphs, tables, diagrams, sketches, figures, mathematics, practical demonstrations, as well as specialist language. In chemistry, there are 3 types of representations that are used to express chemical ideas. These include representations of phenomena using models to explain these phenomena, as well as symbols to support a quantitative explanation. However, in both disciplines, experimental evidence is key in the knowledge building process. Now, the whole notion of representational competence that we looked at refers to how a person uses a variety of perceptions of reality to make sense of and to communicate understandings, whereas representational fluency is the process of translating and moving within and between representations to understand a concept. So we are basically I have 2 hypotheses to look at. We looked at the first one we stated as follows: there's no statistically significant difference between pre-service science teachers' representational competence and fluency in experimentally demonstrating a concept in physics and chemistry. The second one was there's no statistically significant difference between pre-service science teachers' representational competence and fluency in using expert words to explain a concept in physics and chemistry. So these are just the 2 types of representations. As you know, in multiple representations, there are many others, such as graphical and symbolic, etc., etc. But in this particular presentation, I'm just confining it to these 2. So the participants then were a group of second-year Bachelor of Education Natural Sciences students. They made up 40, and what we did was we actually video recorded their lesson presentations in physics as well as in chemistry. Now, what we did then was, first of all, in physics, the students were allowed to build a model to explain a concept in direct current electricity, whereas in chemistry, they could demonstrate a chemical reaction using any household items. And these lessons then were video recorded, and they were analyzed in terms of the students' use of representations to explain the key concepts within those lessons. Excuse me. So what we did was we then counted frequencies of occurrences of excuse me, I can't see the screen now. Sorry, let me just go back there. Excuse me, the competence and the fluency, these were counted. And these range from low level to high level. And so what we were really looking at was, were the students able to integrate across these different types of representations? So for example, if they're doing a particular experiment and explaining it, are the scientific words, the expert words that they are using, are those appropriate? Is it, at what level is it? So we came up in terms of coding these appropriately, like a low level as a 1, a medium level as a 2, and a high level as 3. And at a high level, for example, when they were doing the experiments, they were sort of integrating across all the different types of representations, be it graphical, experimental, using expert words, using symbols, etc. And so here's a shot of a student's attempt at doing a representation of a circuit, in which they were then demonstrating how the circuit works and explaining the concepts underlying this particular section of the work. As opposed to a student doing a reaction between iron and oxygen, and so on. And so that those were the two types of things that we analyzed. So in expert words, for example, they could be saying something like, this is the circuit in which conventional current is flowing from the positive terminal to the negative terminal, etc., and using various appropriate science terms. Then, when it comes to chemistry, we were looking at, whether they were talking to us about, at a submicroscopic level in terms of atoms, molecules, etc., what is actually happening in terms of the reaction. And what we found was the following. We did a chi-square test where we sort of categorized these, and in both instances, we found that there was significant differences in the experimental as well as the expert words in terms of the physics and the chemistry components that the students now presented to us. Then, so essentially, we've got a graph here that shows what actually happened. For example, in the experimental aspect, we found that in chemistry, students were operating sort of at the medium to high level, whereas it was perhaps different in the chemistry section, and likewise, sorry, in terms of using expert words, students were operating sort of at a low level as far as the physics was concerned. Sorry. So both of those, as I indicated, that then means that the null hypotheses were rejected, because this chi-squared statistic was significant at the p equals 0.05 level. And so what we would then be saying is that in terms of just concluding now, that when we as teacher educators are engaging with our students, there's perhaps a need to, focus more on the experimental aspects in physics. And I know Professor Green was alluding to his non-majors and so on. So in a sense, perhaps we at times we saddled with the same problem, with students not having a good enough background. And so perhaps we need to relook this, or rather at this, perhaps focus more on the experimental aspects in physics, and as well as to engage with them in terms of talking and improving their language that they're using in science. So I think I managed to keep within the time limit. So thank you very much.